Okay, so Calc BC Unit 3 Day 9 office hours. Now we did the first two problems as sort of like notes. So then you guys should have tried the next problems on your own. And we'll do them now. Talk about how they're graded. Make sure you get full credit. So point breakdown is going to be 3, 2, 1, 3 for a total of 9. We can use a graphing calculator, GC. So an object moving along a curve, XY plane, parametrics, t is greater than or equal to 0. They're giving you dx dt. They're not giving you dy dt. They are telling you at time 2 the object is at position 1. So that's going to be x1 equals, x2 equals 1 and y2 equals 8. That's the initial condition. So you probably need that for like integration. So A says find the x coordinate of the position of the object at t equals 4. Now, we did a problem like this on a couple problems ago, and we just integrated velocity to get position plus c. You guys can't integrate this. So we have to integrate Vx, which is x prime, right? And that gives you x. But we're going to use the time we want, 4, and the time we know, 2, to help us. So that's going to give you x4 minus x2. And this is what we want, is the position at time 4. So x4 equals x2, which is 1, plus the integral 2 to 4 of 3 plus cosine t squared dt. And we can just use your calculator for that. Now, one, you want to use your calculator to do this no matter what, because it's going to be way faster. Better not making little mistakes like you. Secondly, you guys can't integrate this. You can't integrate cosine t squared. So you don't even want to do that. Now, I'm not going to put my calculator in parametric mode or anything like that. On the AP test, it doesn't need to be parametric mode. It should just be in regular old function mode. Okay, it should be a radio mode. If you feel like we're going to be doing multiple calculations with this equation, we could enter into the Y menu just to have it there. And then you can do the vars, Y vars thing. So from the home screen, I'm going to do 1 plus math 9 vars, Y vars function Y1, or you just type it in again, comma X, comma 2, comma 4. And this should give us the answer. This is why you want to use your calculator. It's so fast. So that's going to be 7.132998. So I'm going to say that x4 equals 3 decimal, actually rounded or truncated, 7.132 or 7.133 if you want to round. Now, there's a lot of points right here. So 1 point for setting up the interval, 1 point for using the initial condition, and 1 point for the final answer. So that's how I do it. Even if you could integrate this by hand and you have a calculator, even the problem we did a couple problems ago, that was no calculator. I did it by hand, okay, because I had to. But if I had a calculator, even though I could do it by hand, I'd be using my calculator. B says at time t equals 2, the value of dy dt is -7. Write equation of the line tangent to the curve at the point x2. So we want to find the equation of the tangent line at x2, y2. Now, you need a point and a slope, right? So we have the point because they gave us this. This is 1/8. So that's the point we're going to use. We need the slope. This is not the slope. The slope we need is dy dx, which is dy dt over dx dt. Okay? And dx dt they gave us was 3 plus cosine t squared, right? The problem is we don't know dy dt as an expression, but they did give us the value at time 2. So specifically at time 2, we know, oh, it's just -7. On the bottom, we got to actually plug 2 in. So it is -7 over 3 plus cosine 4. That's your slope. So, I mean, we could use our calculator to give us that value. 7 divided by 3 plus cosine 4, negative 2.983349. And we could write the equation y minus 8 equals negative 2.983 x minus 1. If you wanted to, you could just put this in instead of the decimal. That'd be exact. That'd be fine. This is 2 points. 1 point for your answer. 1 point for getting the slope. Okay. C, find the speed of the object. So we've talked about this before. Speed is the absolute value of velocity, which in this case is the magnitude of velocity. So velocity is an angle, and it gets broken down into Vx and Vy. We don't really know what the size of velocity is, but if we know the size of the velocity in the x direction and the y direction, then we can use Pythagorean theorem to find it. So it's just really Pythagorean theorem, Vx squared, Vy squared. They're the legs of the right triangle. Take square root. At time at t equals 2, well, that's going to be, we have these expressions, 3 plus cosine of 2 squared plus Vy, that's what they actually told us on the last problem, was -7. So we just plug that in. And so that's going to be, I mean, this is good enough. I mean, we could put our calculator now if you want. Second square root, parentheses, 3 plus cosine 4, close parentheses, squared, plus 49 is 7.382. So this was 1 point, and I think we probably all agree that this seems like a good amount of points for that little amount of work. D says for time greater than or equal to 3, the line tangent to the curve has a slope. So they're telling you tangent line slope is 2t plus 1. Find the acceleration vector of the object. Find the acceleration vector of the object at 4, which is going to be, x double prime at 4, y double prime at 4. Okay, so why didn't they give us this? Like x double prime 4, I think we can get that because we can just take the second derivative. Like we know, acceleration x, which is the derivative of velocity of x, or x double prime, we can get by doing, it's going to be negative sine t squared times the derivative of what's inside 2t, chain rule. We can't do that for y because we don't know what this is, but somehow this is going to help us right here. So dy dx, which is dy dt over dx dt, equals 2t plus 1. We want to know this so that we can take its derivative. And we do know this right here. So we could say, okay, well, dy dt equals dx dt times 2t plus 1. And we know dx dt is 3 plus cosine t squared. So there we go. We've actually created an expression for dy dt, which we need. So acceleration is going to be the next derivative of that. Now, by the way, we do have calculators, so we could just use our calculator to find the derivative, which I think is probably a good idea. Could you do it by hand? Sure. Could you just do it on your calculator? Yes. So, I mean, I would just, for the sake of time and not making mistakes, I would say math 8, and we could actually do vars function y1 times, because that's y1 in our equation right now, parentheses 2x plus 1 close comma x comma, we want it at, well, yeah, we're going to want it at 4. So we have, so this is acceleration y at time 4. Just jump right to that. And then we still need to do acceleration in time 4 for this. So it's going to be negative sine of 16 times 8, which as a decimal is negative 8 sine of 16, 2.303226. So we could write, we can now write the acceleration vector at time 4 is 2.303 comma 24.813. And usually we write it like this. So this was worth 3 points. 1 point for getting velocity in the x direction. 1 point for getting this expression for dy dt. 1 point for getting your final answer correct. Now we could have done this derivative by hand. You could put exact answers in here if you want. You know, I didn't bother finding that, but you could do it if you want instead of decimal. So you could have done this problem without a calculator. I mean, I think a lot of these problems you could, well, other than part A, you could have done all this without a calculator. The calculator definitely speeds it up, makes it faster. Okay, next problem. Graphing calculator. So that was kind of that last problem was kind of interesting because they gave you the velocity x direction, not the y, and you had to do some other creative things. This time, object moving along curve, xy plane, xt, yt, parametrics. Time is restricted this time 0 to 3. They're giving you the velocity equations, right? And at time 2, they're giving you a position. So this is an initial condition. Time 2, x is 4, and this is xy position, and y2 is 5. So you're probably going to need those at some point. A says write an equation for the tangent line of the curve at 4, 5. So we want the equation of the tangent line at 4, 5. Well, you have a point, right? Now you just need the slope, which is dy dx, which is dy dt over dx dt, which they gave you. Okay, we want it, well, what time do we want it? They didn't say anything about what time. What you should realize is that 4 or 5 was just mentioned to you right before this problem. That's the position in time 2. So you need to realize that we're working with time 2. Make that a little tricky. So that means we need dy dx at time 2, which is going to be sine of 3 sine of 4 over cosine of 8. And we could put this in our answer, or we could do a decimal. So it's going to be y minus 5 equals 15.604 x minus 4. So we could have totally done this problem without a calculator. Actually, not that difficult. I mean, you pretty much have the answer. So point breakdown here is going to be 1, 1, 3, 4. So this is 1 point total. Okay, part B says find the speed of the object. Okay, speed should start to feel like easy questions. Speed is the square root of vx squared plus vy squared. So at time 2, speed's going to equal square root of cosine 8 squared plus 3 sine 4 squared. I mean, I guess you could write that as your answer, or you could find it as a. Now we might be using these equations multiple times, so I'm going to go and enter in my y menu. Cosine x to the third. Now I'm just in regular function mode. I'm not in parametric mode. So whenever I hit that variable button, it's giving me x's, even though there's t's, but we'll be fine. Okay. So then on the home screen, we could do, well, I guess that's not going to really help me on this problem so much. Square root of parentheses cosine 8 close squared plus parentheses 3 sine 4 close squared close 2.275. Or you could write the answer like this. You don't have to give decimals on calculator problems. It was only one worth 1 point, which makes sense. Speed's usually going to be like 1 point. C says find the total distance traveled by the object. Ooh, we haven't seen that yet. So total distance is like arc length. Now remember, that's the integral of speed, just like it was last year. But now speed, and we're saying from 0 to 1. So speed, we got to put the actual velocity equations in. We're not plugging time 1 and 0 in yet. You have to integrate first. You need to show your work. You got to show the setup. This is problems worth 3 points. The answer is only 1. Your limits are a point. The integrand is a point. You got to put the dt. Okay. Now I'm going to do this on my calculator for sure. I don't even know if I can pull it off without, but I don't even want it because it'd be horrible. So in my calculator, I'm going to say, I'm going to do math 9, and I'm going to say square root, and then I'm going to say vars, y vars function y1 squared plus vars, y vars function y2 squared. This is a quick way, so I don't have to retype it all out. Close parentheses, comma x, comma 0, comma 1. This is what you want to do it. 1.458. 1 point. Calculator's your friend. All right, part D. That's a lot of points. That's pretty quick and easy for 3 points. Find the position of the object at time 3. So position means x and y coordinates. So we're looking for x3, y3 as an ordered pair by the time we're done. Now, we've done this on a couple other problems. I would use fundamental theorem of calculus. One, just because I have a calculator, even if I can integrate it by hand. Two, you can't integrate these by hand. You can't. Sorry, it's not gonna, you just can't do it. And even if you could, you don't want to. So we want to use fundamental theorem of calculus part one. It says if you integrate a derivative, you get the original function. And if you have some, like we know the value at time 2 and we want the value at time 3, then you plug limits in, right? We can do this for each of them. So for y, it's going to be y prime. If you integrate y prime, you get y. From 2 to 3, you're going to get 3 minus 2. So now we just got to, keep showing the setup. We want this and this, right? So x3 equals x2 we know is 4 and y2 is 5. So that's going to be 4 plus 2 to 3 of cosine t cubed dt. And then we're just going to write the answer. Use our calculator. Write the answer with the calculator. This is going to be y3 equals 5 plus 2 to 3 of 3 sine t squared dt. But you got to show the setup. And then we're going to write down the answer y3. And we're just going to do this on our calculator. So this is worth 4 points. But if you're using your calculator, it's not bad. So 1 point here, 1 point for this answer, 1 point for this answer, 1 point for using the interval there. So my calculator, I'm going to do 4 plus math 9 vars y vars function y1 comma x. I think it paid off putting those into that y menu. 2 comma 3. This should be my answer. 3.953 or 3.954 if you really want to round. Okay, and the other one's going to be, I could just do, I can do copy paste, change the 4 to a 5 and change y1 to vars, y vars function y2. I don't know if that saved me a little bit of time. 4.906. And then I think we should write the answer as ordered pair, 3.953, comma 4.906. So generally all these answers in parametrics are going to be written as x and y components, x first, y second. So there you go. One more. So this is another graph and calculus problem. Get a little graph this time. Okay. This figure above shows the path traveled by a roller coaster over the time interval 0 to 18 seconds. So this is x and y, but this is indicating this is parametrics. Position of the car at time t seconds can be modeled parametrically by, so they're giving you the x and y position equations where x and y are measured. The derivatives are given, and they're giving you the derivatives. Now, by the way, could we have gotten these derivatives ourselves? Yeah, but whatever, we'll take them. Why not? I mean, derivative 10t is 10, derivative 4 sine t is 4 cosine t. They're not helping us out that much, but whatever. A, find the slope of the path at time 2 should the computations lead your answer. So we're trying to find the slope at time 2. So that's going to be dy dx, right, at time 2, which is going to be dy dt over dx dt at time 2. And we have all these, so it means we're going to plug 2 into there. And then, I mean, we could use our calculator to get the answer. Now, I'm going to go ahead and, I don't know if I want to enter all these in here. I mean, we could just put them all in here and just remember where they're at. I'm assuming hopefully this is worth this and it didn't take too much time. Okay, so I got those all in here. I'll just remember I entered in the order I saw them. Y1, Y2, Y3, Y4. I mean, you can write little notes to yourself. You shouldn't use this in your work, I don't think, but okay. Let's see. I mean, we can just type these in. 18 sine 2 plus cosine 2 minus 1 divided by parentheses 10 plus 4 cosine 2 is 1.793 or 1.794. Either way, the point breakdown here is going to be 1, 2, 3, 3. I think part A seems only worthy of 1 point. Just got to get the answer correct. B says, find the acceleration vector of the car at the time when the car's horizontal position is x equals 140. So looking for the acceleration vector at this time. Well, what time is that? So I think we're going to have to figure out what time this is true. So when we have the x equation, xt equals 10t plus 4 sine t. And we want to know when is it equal to 140 and find the time for that. So I'm going to solve that on my calculator. I'm going to go to y equals, I'm going to actually turn these off right now. I'll still be able to use them for calculations. And I'm going to put this in tx plus 4 sine t minus 140 so that I can just look for the x-intercept. Now I know I'm only concerned with, I think, 0 to 18. I'm going to go to window, 0 to 18. I'm only concerned about trying to find the x-intercept of this graph, so I'm going to say negative 1 to 1. And there should probably just be one answer right there. Now, by the way, you also from the graph can tell that's like right around here. This is when x is 140. But you can't tell what time it is. But now this should be the time. Second calc 0. This was 0 to 18. So I'm just going to say 9 to 18, guess 14. So there it is. 13.647083. I'm carrying extra decimals here because I got to plug this into something else to find another answer. So you should not be rounding and truncating 3 decimals. This isn't even an answer. This is to help you to find the answer. Now, to find the acceleration vector at this time, 13.647083, then you're going to need to take the derivative, second derivative at that time, 13.647083, and the second derivative for y. This is actually going to be pretty quick and easy because I'm using my calculator. So on my calculator, I mean, could you do these derivatives? Could you find the acceleration by hand? Sure. But I'm going to get rid of this. I don't need that anymore. On the home screen, I'm going to do math 8 bars, y bars, function y3. I'm going to take the derivative of x prime to get x double prime, right? Comma, x, comma, 1.793 3 was at that time. Oh, shoot. 13.647083, right? So that'll give me the first part, negative 3.529. And then the next one, it's going to be the same thing. I'm going to change this vars function y4, 1.225. That should be your final answer. Or 1.226. But that's it. So that's 2 points. 1 point for, I mean, they actually took the second derivatives by hand, but I don't know. Okay, we could have done a lot more work by hand there, but I don't think that makes sense when you have a calculator do it. Okay, C says find the time at t at which the car is at its maximum height and find the speed meters per second of the car at this time. We actually have units here, meters. I mean, we could say that the first one, well, the first one's slope, everything cancels out. This one, this is meters per second squared. X is meters, T is in seconds. Okay, so we're trying to find maximum height, the time when it's the max height, and then find the speed there. So this is looking for max height, the EVT problem, which means we're looking for max Y. Okay, and so we need to, that's going to happen at a horizontal tangent when dy dx equals 0, or more specifically when dy dt equals 0. And we have that expression, that's 20 minus t sine t plus cosine t minus 1. So I'm using my calculator to solve this now. This is actually my y4 equation. So I can go down here and just turn this guy on and then graph it and look for the x-intercept. So there it is. And there's another one. There's another one. Oh my gosh. Wow, these are all critical points. So t equals second calc. I mean, I don't know. I don't think I want to try and solve that by hand either. 0. Looks like there's one around 3, so I'm going to say 2 to 4, guess 3. I thought maybe it'd be like pi or something. 3.0239158. Carrying extra decimals. I got to use these for future calculations. So we need to keep going. Find all these. Second calc. 0. Looks like there's one around 6 point something. So I'm going to say 6 to 7. Guess 6.5. That one's 6.283183. Next one, so I can calculate 0. It looks like it's round 6, 7, 8, 9. So I'm going to say 8 to 10, guess 9. 9.239446.2. Next one, so I can calculate 0. Looks like it's around 10, 11, 12 and a half. Let's say 12 to 13, guess 12.5. 12.5666371, and then one more so I can calculate 0. 13, 14, 15 and a half, so I need 15 to 16, guess 15.5. Oh, sorry. 15 to 16, guess 15.5. Wow, that's a lot of critical points. We have endpoints. Endpoints are 0 to 18. And so then we need to make a table. And table, endpoints, critical points. Wow. A little tedious. And we want to plug these into the height equation, which is this one. Right? We could do this quickly on our calculator using the table function, right? So I'd go to y equals, turn that guy off now, go up here, and turn the second one on, and then go to table and just type these values in: 0, 3.0239158, 6.2831853, 9.2394462, 12.566371, 15.289584, 18. It's a lot of numbers. Okay, now I'm going to write these down here. 0, and I want more than 3 decimal accuracy. Maybe my work 33.834762. So if you look at what it displays, it rounds it, which you might not want yet. So if you highlight it, it shows you more accurate version there. Wow, that's interesting. 0. And 21.336834. And then 0 again. And then 9.014552. And then 0.679366. Now, by the way, we have a picture of this graph. We're looking for the max height, which I'm pretty sure is right here, right? So that should be the one. Now, the 0 ones are these ones, right? And then these are the other relative maxes, mins, and we're checking the endpoints. So, you still got to show your work though. But this is the max, just like I said. It's that first number. So, let's see. We should write this answer. It says find the time of the car's at max height. So we can say the car is at its maximum height of 33.834 meters at time t equals 3.023 seconds by extreme value theorem. Checking endpoints and critical points. Okay. It then says to find the speed at that time. So speed is the square root of velocity in the x direction squared, velocity in the y direction squared. So we just need to plug this time in to those equations. So 10 plus 4 cosine 3.0239158 squared, and then 20 minus 3.0239158 239,158 sine of 3.0. I don't know if we need to write all this, but why not? I'm already committed. Anyways, that's what it is. We could use the table to just get us the decimal values, but oh, now here's something interesting. Well, whatever. Yeah, let's go ahead and do it. Now remember the way we found these points was by setting dy dt to 0. So by the way, this should just come out to 0. So then you should just get this as your answer, because then this is 0, square root n is a squared. This is your answer. Plug that in your calculator. We could use the table to help us. I don't know, might save a little bit of time. And then there's the value there, by the way. Anyway, so there's the value, 6.027. If you go over here, it doesn't quite say 0, but it's pretty much 0, right? It's 6 zeros after the decimal point before the first number. It should be 0, but the calculator is a little bit off. Okay, so there we go. One more question. Part D says, for 0 to 18, there are 2 times at which the car is at ground level, y equals 0. Find these 2 times and write expression that gives the average speed in meters per second of the car between these 2 points. Do not evaluate the expression. So we're trying to find the 2. I'm going to write it up here at the top. D, we're trying to find when y equals 0. So y equals 20 minus t, 1 minus cosine t equals 0. This is going to be easy to do on our calculator. So I'm going to go to y equals, I'm going to turn the y2 on, right? I'm going to turn the other ones off. And then I'm going to graph it. Oh, are those the 2 times right there? Like it barely hits 0, which look at your graph here and here. So it kind of makes sense. So second calc, I mean, we could solve this by hand, I feel like, so easily. It's 20 minus t equals 0. T equals 20 is an answer. 1 minus cosine t equals 0. Cosine equals 1. So that's going to be at 0 plus 2 pi k. And we're looking for times between 0 and 18. So this one's outside of 0 to 18. So still seems potentially actually it says 0 to 18 but not including 0 and 18. So this would be 0, 2 pi, 4 pi, 6 pi, and that one's out. This one's going to be more than 18. So it's got to be these 2 times, 2 pi and 4 pi. Or you could use your calculator, like I was doing. And we could do 0 and say, oh, 1, 2, 3, 4, 5, 6, between 6 and 7. And hopefully it finds it. 6.283186.4. And then the other one, so I can calculate 0. Looks like that was 6, 7, 8, 9, 10, 11, 12. 12 to 13, guess 12.5. 12.56637, which are really close to 2 pi and 4 pi. So we found those. So we could say that seconds, or we could round 6.283, round or truncate. So you could do that. So that's the first part. Now it says to find the average speed. That sounds like mean value theorem. So this one's a little tough. A lot of times on last parts of first one's questions, they like to throw you something a little tough. So average speed. Now remember, speed is the square root of the velocity in the x direction squared plus the velocity in the y direction squared. And so if we want to find the average, well, that's mean value theorem. Okay, and I know speed's related to derivatives, but this isn't like straightforward just a derivative. So we're going to use a regular mean value theorem for any kind of function. So average speed is going to equal the integral of speed from, they said, between these two times from 2 pi to 4 pi, or you could use the decimals, and then divide by the base. Okay, so it's going to be 1 over 2 pi, the integral from 2 pi to 4 pi of this. Now, because these are already defined in the problem x prime t and y prime t, we could just totally just write these. We don't have to write the whole expressions for those. But this is the setup. And it said not to evaluate it. So I think this would be good enough. Okay. I mean, we could write it, I guess nicer if you really want. And you could also put those decimals in there, which would be kind of annoying. So I kind of like the answers I got. But you would have to write, you could write all this stuff, 10 plus 4 cosine t squared plus 20 minus t sine t plus cosine t minus 1 squared dt. You could write that too if you want, but so finding the time was worth a point, setting y equal to 0 is worth a point, and then finally this last part was worth a point. So it was a lot of work for 1 point. So don't get too worried when you get a weird part of a question on part D. Don't let it discourage you too much. All right.